Okay, good morning to the other panelists, Mark and Stephanie. Good morning to everyone that's joining us. Looks like we'll have a few more people straggling in as we go here. So, but in order to keep a timeline, I think we'll get started. So everyone can hear me? Mark, give me a thumbs up because you're the only screen I see. Yeah, great. Thank you. So yeah, I'd just like to thank you all for joining us today. And I hope you all get some good takeaways from today's session. This will be a three-part webinar, starting with a brief overview of where the City of Penticton is with referencing the BC Energy Step Code, followed by Stephanie from Fortis. She'll be updating us on the Fortis rebate program and the newest up-to-date rebates for Part 9 and for Part 3 buildings. Then we'll be followed by Mark Bernhardt. He's going to be giving us a presentation on HVAC systems and performance building and how we can reach the higher steps of the BC Energy Step Code. So then we'll just do a little Q&A and a little wrap up at the end. You can ask questions during, you can put them in the chat, and we will give time at the end of each segment for anyone to ask questions, and we will do our best to answer them all. If you do have any questions after the fact, you can always contact me here at the City of Penticton, and I could get those questions answered for you. So. We are offering 2 CPD points for those of you that require them. I just ask that you fill out the survey at the end, and you must have full attendance for the 2 hours to receive them. They will be mailed out in the coming days. So, and then lastly, I'd like to just acknowledge Fortis BC for their support in bringing these educational webinars to you all. So, excuse me. So let's get started here. So just a quick recap, the City of Penticton is currently referencing step 3 of the BC Energy Step Code for Part 9 residential buildings, as most of the people joining us are probably well aware. That includes SFDs, 3 and 4-plex units, row housing, low-rise construction, and accessory suites. So by early next year, we do have it in our mandated in our building bylaw now. We will be referencing step 1 of the BC Energy Step Code for certain Part 3 archetypes. So some of those would be the Group C residential, 6 stories or less and non-combustible, Group C greater than 6 stories or non-combustible, Group D business and personal services, and Group E mercantile occupancies. So just a few items actually while we're speaking about the bylaw. So a few changes have come into effect, and I'll tell you about them here. So any applications after July 1st this year, we now require a mid-construction compliance report prior to calling for insulation or vapor barrier inspection. So this should be thought of as like not an extra step per se, but as a tool to engage with your energy advisor, ensure you will meet the higher steps of the BC Energy Step Code. With that, the City of Penticton is offering a $250 mid-blower door test rebate through the end of this year. Thank you to Fortis's BC support once again. And also a 5% building permit fee rebate or reduction for any dwelling which achieves a minimum of step 4 of the BC Energy Step Code at time of occupancy. So you can find more information on the web address at the bottom here. If you can see my mouse just right there. So. And then the city has now adopted as well the EnerGuide labeling system for all new SFDs and accessory suites. This early adoption is in the anticipation of mandatory requirement in a couple of years. So the province has committed to requiring labeling at point of listing on MLS. The province's intent is to have a labeling tool and a platform up and running at least a year ahead of that. So later on this year or early next year. So the industry and stakeholders have an ample opportunity to use it, test it, and be comfortable with it before it becomes mandatory. So you can speak with your EA about getting that label. And here's just a shot of the label and what we're looking for. So just like an appliance, the lower the number, the better. So it's a pretty good label. You can go on Enercan's site and read all about it. And if you're not familiar with it already, but I'm sure you are fairly familiar with it. I mean, we have this label for our appliances. We have similar labels that we relied on for our vehicles. So I guess with your house, you know, you should think of your house as an appliance too. It only makes sense to have this label for probably the biggest investment of your life. So the question arises, how is achieving higher steps of the BC Energy Step Code done effectively and affordably? Well, that's what we're going to talk to you a little bit about today. So as I've stated in previous workshops, you know, one of the main key factors in the early design considerations done through the integrated design process. So the designers, builders, trades have to all know specific requirements, code related and occupant related, to achieve maximum efficiency without sacrificing quality and cost overruns. So since today we are focusing on mechanical, it is imperative the mechanical contractors know what the goal of the project is before the project is started, basically. You know, we used to rely on the good old rule of thumb method, but you can't do that anymore because you'll just end up with a poor performing, oversized, and often overpriced system. And just one of the commonly accepted old estimates or rules of thumbs is like a cooling unit should provide 1,200 BTUs or 1 ton of cooling for every 400 to 500 square feet of building area. However, this rule doesn't take into effect local climate and how well a house is sealed and insulated. In a very energy efficient house, 1 ton can condition up to, and in some cases over 1,000 square feet. So rules of thumb don't work in highly efficient buildings. So when you look at this diagram, there are many different components involved when trying to determine the right age. There are 3 main metrics involved in achieving higher steps of the BC Energy Step Code. You have your MUI, your mechanical energy use intensity, your TUI, your thermal energy demand intensity, and of course, your air tightness. So our guest speaker, Mark, he's going to be speaking more to these metrics, so I'm not going to get into them too much. I'm sure a lot of you are well aware of these metrics already. So So these 3 metrics encompass everything you see here and actually more. So always keep in mind, like the building as a whole system when designing, and achieving metrics will become easier. The lower the mechanical energy use, the lower the resulting MUI. Air tightness minimizes heat transfer, requiring less thermal energy to heat or cool the home, resulting in a lower TEDI. And then balancing and air pressure is another key piece of the puzzle to ensure your HVAC is operating effectively and efficiently. So both Part 9 and Part 3 buildings can use a variety of options as long as the systems are designed and modeled for compliance with the BC Energy Step Code metrics. So one of the things we always wonder is, you know, can I afford to use these new technologies or high efficiency systems? Well, don't believe the myth that you can't and that they're going to cost you a bunch more money. Do the research, model the building with the design components, and you may be surprised. I want to do a quick breakdown on high efficiency systems, or coefficient of performance, commonly called COP, which is generally used for appliances such as heat pump that would have over 100% efficiency. So basically how it works is, let's take, for example, a baseboard heater. It's considered 100% efficient as you get 1 unit of heat for every unit of electricity. A heat pump can get upwards of 300% efficiency nowadays because of every unit of electricity you purchase, you can get 3 units of heat from that. So a fuel-fired appliance, such as natural gas, is less than 100% efficiency, so a COP. Still hear me? Oh, there we go. Can you hear me now? Okay, thank you. And then there's also a combi system, which could include an air source heat pump and gas-fired backup. Oh, man. Sorry, everyone. Having a little difficulties with my. We're good still? Yeah, okay, thank you. But this system's efficiency would be considered less than 100% when it runs on natural gas. So. And then the other thing we got to look at when we're thinking about our systems, and today we're talking about HVAC, but this accounts for everything, is our net present value. And it's basically a measure of the life cycle cost analysis of a material or a component. And it compares the cost effectiveness of systems, components, and operating and maintenance over the life of the appliance in this case. And this can be a very elaborate calculation. You can focus way too much energy on this, or you can just kind of keep it simple to get an average value of using high efficiency systems. So keeping it simple, just a really fast example. So if you save 38 bucks a month on your heating bill by installing a heat pump that cost 5,000 less than, say, a new $25,000 gas furnace install, and they are both expected a 20-year lifespan. If you do the fast math in it, you've just almost saved 15,000 over the lifespan of the appliance in operating costs and what you would save off the hop. So, I mean, that's a very simple net present value, but I guess the point I'm getting at here is you consider the upfront costs in specific equipment, because your long-term savings could definitely benefit you. I should note, though, that cost savings on efficient appliances really depends on the local price of energy, whether it be gas, electric, or both, and current rebates and incentives from local suppliers and government. And in a few minutes here, Stephanie's going to speak to the local rebates that Fortis is offering. So talk with your EA and your mechanical designer early in the build and see what your modeling tells you. I would like to point out, though, that energy modeling, like HOT 2000, is basically measuring apples to apples based on a national compliance. So whereas like a standard, say as F28012, is used to determining like size from a calculation method, taking things into account such as energy used, building size, velocities. So, but with the integrated design process, good engineering practice, use of a standard, and energy modeling, buildings should easily meet performance metrics of higher steps of the BC Energy Step Code for your climate zone. So that's my little spiel for now. We're gonna just pass this along to Stephanie here, and she's gonna give us a little rundown of the rebates. So I'm gonna stop sharing my screen here. Stephanie, you want to take over?
Yeah, sure. Hi, Ryan. Thanks for the introduction there. That was great. I think I have 15 minutes here to present my slides. I will share my screen and let me know if everything looks good. just a moment here. We use Teams most often, so I always have to look for all the features.
Yeah, no problem.
Okay, there we go. How's that?
Yeah, that's good. We can see it.
Okay, you can see my screen, you can hear me. That's perfect.
Yeah, you're good to go.
It's all we can ask in the digital era.
That's right.
Still good? Or do you see the flip probably?
Yeah, I see your
You see all the notes and stuff
I
on
see
the
your
side?
notes and
Yeah,
stuff.
we're seeing presentation mode. You want to go to reading view.
Okay, yeah, let me do that. There we go.
Yeah, that's
Perfect.
good.
Okay, hi everyone. I'm Stephanie O. I'm the Energy Solutions Manager for Conservation and Energy Management for the commercial customer base in the interior and northern BC. I'm here in Kelowna, so not too far away from all of you here. My screen background is of our beautiful Lake Okanagan. So Ryan asked me here today to speak to you a bit about our different rebates that we have, and I will cover in general both the commercial and the residential side. So 15 minutes kind of gives us a bit of a chance to get an overview, and then we can, if you have questions afterwards, definitely happy to answer them, or we have contact information on all our web pages. So we'll go over the rebates, why we have them in general, how do you go and find them? We have the residential rebates, and we'll dig in a bit more to the new home program and the IDP process that Ryan had been speaking to, and then a bit about our commercial performance and our commercial product rebates. So in terms of energy efficiency and rebates, you've probably heard a lot from us these days about our 30 by 30 target that we hope to reduce our emissions by 30% by the year 2030. And a huge portion of that for us will be our energy efficiency incentives. We have more rebates than ever. Since 2019, we've been tripling our spend on these programs. And through to the end of next year, we will have spent that large sum there, over 368 million is our target to put into these initiatives and efforts to help our customers with their goals in terms of energy efficiency and emissions reductions. In terms of the best way to go and see our programs, we regularly update them on our website. I don't know if any of you have been there recently, but we have more than ever listed there. And it is the best way to get the most up-to-date information. So fortisbc.com, and then luckily in Penticton, you have access to both our gas and our electric rebates. So that's nice and easy for you. They're all there. You can utilize all of them. And then in terms of the types of rebates that we have that you would be interested in, we typically classify them into two different categories. So we have our performance rebates for high performance buildings, and those are best taken advantage of early in the design phase, and they give you access to the highest tier rebates. And then we also have product rebates that can be accessed on the back end most typically, and it's easy enough. You buy eligible equipment that falls under our list. Those are typically, they're often Energy Star certified or follow one of those other certification processes that demonstrate that they're energy efficient, and then we're able to provide a rebate for them. So you can go online, and then our website there, we have a section designated to rebates and energy savings, and then drop down to rebates and offers. And then from there, you have both the For Homes tab and then the For Business tab that allows you access to either stream. In terms of, I know we talk a lot about Part 9 versus Part 3, but for our rebates, we typically split them based on commercial versus residential metering. So if you have a standard home and it has a residential meter, it's going to have a residential rate. That will be your, you'll be accessing the residential rebates. And then if you have a business and it has one of our commercial business rates, then you would be accessing the commercial rebates. That's typically how things work. Sometimes we can make some exceptions depending on whether or not the customer finds a fit, but it's always worth asking us if that's something you need. Onto our residential rebates. So these are the types of structures that are typically covered. So you have your detached house, your attached house, like your semis, your duplexes, townhouses, row houses. And then we offer two main streams under those. So we have the new home program, which will be more of the focus that we have here today in our chat, because I think that's the main topic of interest. It's a bit more complex. So that would be for your high performance homes going for its step code. And then it has the energy advisor support rebates in there, along with energy efficient appliances. And then we have the design offer that we will also talk about. And the second stream there is for the home renovation rebate. So that's if you have pre-existing equipment that you are upgrading to new products or other types of equipment, just depending on what you're looking at. We have rebates for furnace replacements and water heater replacements, insulation, windows, and so on. So definitely take a look if you plan on doing any upgrades. It's always worth it to check it out first. So this next slide here is about our new home program. I don't typically work on residential, but Nathan is the program specialist for the new home program, and he was kind enough to kind of walk me through the details that you might find interesting today. Ryan, I know that your audience had a number of questions about this program, so if you feel that I miss anything as I go over this, definitely feel free to chime in. Or yeah,
definitely.
Go ahead.
No, I definitely I will chime in, and I encourage anyone that has any questions about these rebates to ask Stephanie while she's here. So
or take down that contact information. And,
right.
and Nathan said he'd be happy to receive your questions.
Yeah, perfect.
Perfect. So basically, I'm looking at this first part, and it's the design offer. It's something that's newer to market. I believe we only released it last year, and there's potentially still some confusion around it. So for the design offer, you would want to approach it prior to getting your building permits. And one of the key parts of the design offer is the integrated design process, which Ryan has been speaking to, and I know Mark knows a lot about, so he'll probably speak to it a bit more as well. And if you choose to go that pathway, you would have to go and find a pre-approved IDP facilitator. And the best way to go about that is actually to email Nathan, and he would send you the most up-to-date list, because currently the number of folks out there that can perform this is not that large as of yet, since it's a growing area of expertise. And the thing is, if you do try to go with the IDP facilitator, they will always be an energy advisor. So when you're working with an energy advisor, and if you choose someone who is IDP qualified, they would be able to help you throughout the whole process of this rebate, which is fantastic. And so you would automatically get that $1,000 rebate for, basically we provide the rebates to get the consultant services. So you get the rebate for the IDP facilitator, and in turn, they would be able to guide the process for both envelope design and mechanical design. And then you would be able to get up to $6,000 in rebates for services for those two items as well. So essentially, if you participate in IDP, you would also get envelope and mechanical. However, if you don't choose to do IDP, you could still access envelope design or mechanical design individually. And you can bring your own qualified consultant. We do have a list available online, but you don't have to go with them. And then in terms of how many, because some of you will be building multifamily complexes, we do allow this offer for unique designs within those complexes. So anything that would need different mechanical or different building envelope could be included. Yeah, and the idea is that we want to support early planning with this program. And so we also say that it is currently available until December 31st, 2022. And when you see that online on the website, it actually is alluding to the fact that it will be there until that time. However, it still may continue afterwards, but the program structure may change. So if you're interested in this program, the best, and your building permit will be before that date, that's what locks in this program structure. I'm going to move on to the next slide as well. It digs in a bit more into the different tiers of the new home program. So I understand Penticton is currently at step 3 for Part 9 residential, and you can still access that rebate tier by going through that program. That's not a problem. And like I said, if you get your building permit before December 31st, 2022, you'll lock in that structure. And then we have the rebates there available for the energy advisors support and for the additional rebates. And then the energy advisor that you're working with would be able to submit the application on your behalf. And the applications must be submitted within 6 months of project completion. I'm going to continue moving just to give you a quick skim of our other programs. I know time actually passes very quickly here. The next ones would be our commercial performance rebates that I have for you here. So the newest program that we've added is the small commercial new construction program. And so previously we had a gap for buildings that were being built to step code 2 or higher that were under 50,000 square feet. So now we have a program that supports that. And we've tried to make it a bit more prescriptive, whereas if you are building to that level of building, you can apply at the end with all of the required documents. We're currently looking at building permits that are starting January 1st, 2022. But if you have a project currently that you're interested in pursuing that program, please feel free to let me know. I am able to get some exceptions if it is the best program that fits for you at this time, prior to that January 1st, 2022 date. And then for the commercial new construction performance program, it also follows the same tiers as the small commercial new construction. So essentially we're giving $1 per square feet for step 2, and then it's $1.60 per square foot for step 3, and then it's $2.20, I believe, for step 4. We don't see as many of those. I see most probably in the step 3 region for commercial new construction. And there are a few builders already in Penticton that are using the large program. So we have High Street Ventures, Mission Group, and there was one more. Let me look. There was one more. West Urban is also building in Penticton using the commercial new construction performance program. And so the larger buildings do require more effort up front, and they do require pre-approval because we would have to do all of the energy studies and the applications going through our program first. And then we have different points within the program where we're able to offer incentive amounts, like for the energy model. And then we would offer our first 10% and then a 90% on completion. And then we also have air tightness testing rebates, as well as more rebates for that energy model funding. Moving on to our product rebates, some that might be of interest. We have this new multi-unit residential building rebate, and that's actually closing out in the market at the end of this year. It allows access to both the commercial equipment as well as the high efficient in-suite equipment, but this program also needs pre-application. And so that would need to be done prior to the end of this year in order to still get access to that program. We have commercial lighting rebates where we also can offer point of sale through our trade ally network. So that's a good offering as well. We have the condensing makeup air program, which is a slightly newer offering. So this technology isn't as prevalent in the market just yet. It's for indirect fired gas units that are over 90% efficient due to that condensing technology. But we're starting to see them be taken up more in new MURBs, as well as new condos and new hotels. And then we have some that have even been going into like hospitals and other facilities such as that. And the last on this page here that might be of interest to you are natural gas boiler rebates. We are currently we're currently providing $12 per MBH for anything that's applied for within this year. And then moving through to next year, it'll be back down to $9 per MBH. And this is for your high efficiency gas boilers and commercial buildings. And then for our natural gas water heater rebates, those are very popular in this region. And then we also have heat pump and electric water heater rebates. And when they say electric water heater rebates, those are also water heater heat pumps that they're providing incentives for. So just a bit over time there, Ryan. I don't know if you wanted to move on or see if there's any questions at this time, whatever works best for you.
Yeah, I think we're okay for if anyone has a couple questions. I would actually like to just ask one. The commercial plan, it doesn't necessarily have to be a Part 3 building. It could be a Part 9 building involved in that as well.
Are we talking back to this slide maybe, or just commercial in general?
Just this slide, yeah. The small commercial, I guess that could be Part 3 or Part 9 building.
It really depends because if you have a really small commercial building that's going for this, then they would fall under Part 9 most likely. But I would assume that they're commercially metered at being a business, and then they would be able to participate in this program.
Okay, thank you.
So we're really looking at the rates on our side. Do you have a residential rate for that meter or a commercial rate for that meter?
Okay, good. Would anyone else have any questions? You can type them in the chat if needs be, or you can raise your hand.
Sorry I had to go through that so quickly. I always think you have more time than you do.
Oh, that's okay.
I don't know where my chat box went. It's hidden somewhere.
So far, no.
Okay.
But thank you, Stephanie. I appreciate all the information, and of course, you can go to the website and get any more information, or maybe some of you might have copied down that email address of Nathan. It was.
Yeah, or you can send them, like Ryan said, you can send them to Ryan, or you can send them to me, and I'm happy to pass them on to the rest of my colleagues. We have a really good network of folks that work with us. Like I work on the commercial side with a commercial team, but the residential side also has a residential team for new home. They have a residential team for the home renovation rebates. So we're looking out to help you. So feel free to contact us at whatever email you can find here or online, and we'll try our best to answer that or get it to the right person.
Great. All right. Well, thank you very much, Stephanie. Appreciate you
Yeah,
taking the time out of your
problem.
day. Yeah.
Thanks for having me here today.
Yeah. All right. Well, let's move on to Mark.
Excellent. Well, great. Yeah, thanks for having me. I just want to confirm that we can see slides again. Switched. Yep. Okay.
Yeah, you're
great.
Good to go.
All right. Well, thanks for coming, everyone. Happy to be here. Thanks to Stephanie and Ryan doing our intro there. So I was asked to come and talk about mechanical systems and step code and kind of how they work together. How we can use the step code to get better results for our mechanical systems and whatnot. And so there's a lot of things going on here, and I'm going to talk today mostly about Part 9, although the principles do apply to Part 3 buildings. The systems might be a little different, a little bigger, maybe a little different laid out, maybe a few more options, actually better controls and things like that. But generally, the principles are exactly the same. And I'm not running off of a set script here, so if folks want to throw questions in the chat or in the Q&A, I'll keep an eye out for them and answer them if I can. If we don't get to them, we'll save some time at the end to deal with that. And I suppose for those that don't know me, I'm Mark Bernhardt. I'm a certified energy advisor. I'm also a licensed builder. And although we're doing a lot less building these days, a lot more on the consulting side these days, and we're based out of Victoria. Our our main office is there, but we also have satellite offices in Qualicum Beach and in Kamloops. So we're kind of spread out around the province doing energy consulting and various different things. Our day-to-day bread and butter these days is the STEP code, as well as all these rebate programs that are flying around, both on the retrofit and the new building side. So we've participated in the Fortis programs quite extensively. I'm on that list of people who are certified for the integrated design process, and highly recommend folks take advantage of that. And I can tell you those programs are good. The checks arrive in about 2 weeks from the application, so it's pretty easy to use, pretty easy for your energy advisor to take you through. So let's get started. Let's talk about this here. So on our agenda today, just going to do a real quick overview of what we're looking at on the STEP code metrics. We're gonna dig into the MUI and the percent better. These are the two metrics that focus on mechanical specifically, or mostly on mechanical, I should say. And then I'm also going to talk a bit about using the data that your energy advisor gives you to right size your mechanical. Talk a bit about ventilation, and I guess we've already talked about rebates. That's maybe a bit out of order there. So the STEP code itself here, if you've looked through the STEP code manual, the one that's available online, you would have seen this table. And I want to encourage everybody on here to basically ignore the numbers below the table here. Those are for your energy advisor. I don't have them memorized, and I work with this every day. What's really important is that we understand that there are three main categories that STEP code operates on. And that's the air tightness, the mechanical energy or systems and equipment, and the building envelope. And both part 3 and part 9 have the same categories. The metrics are a little bit different, but it's the same sort of idea. And that, I think, is important for us to understand that there are the 3 categories that we have to meet. And today we're going to mostly focus on that green one, which is the systems and equipment. The building envelope and actually air tightness are a whole different presentation in themselves, and hopefully you have a chance to attend some education on that as well, because they are interesting in their own right. Quick update that is coming. We don't have an exact date on it yet, although it has been committed to. Provincial government has done this. Now it's not quite in the law yet, I don't think, but it will be coming soon. Is an update to include the greenhouse gas emissions into the code. And this will have some pretty dramatic effects on how we heat our buildings in particular. So the thinking is right now, at least the trend, we'll see what actually gets signed into law here, but the thinking right now is that the first step, starting at step 3, would just be reporting, so that you have to report what your operating greenhouse gases are, which is already done. Actually, that is already included in the STEP code permit forms. It's already there. That would be no change from where we are today. And then step 4, you might have to use less CO2. So in some areas, that might mean you could have your heating or your hot water on gas, but maybe not both, depending on what type of system you're using. And then at step 5, it would be much less. So in areas like mine in Victoria, that probably means we're mostly fully electric. In areas in the far north, there's talk that might mean you can still use gas as heating, and it would be sort of a sliding scale sort of thing. So something that folks are watching pretty closely, and certainly something to watch for in the future. So the MUI, the mechanical energy use intensity. This is the metric we're going to spend most of our time on today, and I want to just give a quick definition of this one here. It is the energy use of your home, your home's mechanical systems, and actually other systems as well, divided per square meter of floor area. So the key influences on this are the efficiency of your heating system and the efficiency of your hot water system. Those are the two biggest things if we're talking about a Part 9 building. Now, the important thing to remember is that this does not consider fuel type. So we are going to get to that in a little bit, why that matters, but it does not consider whether you are using gas or electricity. A little more detail on this one. So the MUI is actually your total energy use minus your base loads for Part 9 residential. If you're talking about Part 3, it's just the total energy use. And that's an important difference because in Part 3, we might have like 100 units in a building, and you can get a kind of average baseline of what the base loads might be. Base loads are like your TV, your fridge, things like that. So in a big building, we can get a nice average and we can use the total energy with reasonable credibility. In Part 9 building, we've got one family probably doing kind of crazy things, maybe doesn't know how to use their fridge, and the base loads can be all over the place. So that's why we exclude base loads from Part 9, and we don't in Part 3. And all of that is divided per square meter of floor area. And so just a little bit more about what's in that number, right? And it's not just it's not just the heating and the cooling, right? It is actually your hot water, your ventilation, and things like that. So you'll quite often see if you insulate your house better, your MUI will also drop. And that's because it is that total energy, right? So heating energy is included in your total energy. So the TEDI and the MUI are related, or that envelope metric and the mechanical metric are related to each other. So if you have a very efficient house, it is easier to meet the other metrics as well. And of course, all of that is divided per square meter of floor area. So if you imagine a block of energy that is your mechanical energy or your total energy, it's all divided per square meter of floor area. So the more mechanical energy you have, the more you'll have per square meter of floor area. And so this, of course, has consequences as well for buildings that might have features like open to belows or less floor area compared to their energy use. If you have an open to below, some atrium looks fantastic, but it's not counted as floor area. So you have less floor area to divide your energy over, and that can give you somewhat of a disadvantage. And that's why I've often been heard predicting that open to below as a design feature, or atriums in larger buildings as a design feature, will probably fade away, at least on the kind of value end of the spectrum. The cheaper houses, they're probably going to see that fade away. The more expensive houses, people building the mega mansions and stuff like that, those folks are always going to be able to afford to pay for kind of whatever they want. And I'm not too worried about those folks. They'll still be able to get whatever they want. But the value end of the spectrum, probably going to see that fade away as a feature. Now, the second part of that metric, category there, that green category, there's two. There's the mechanical energy use intensity, and there's the percent better than the reference house. And it's an either or. You can use either or for this part here. Now, the reference house is honestly, it's a bit goofy, and it does disappear at step 5. So it's a metric that was put in because people were somewhat familiar with it, and the idea being that it then fades away at the higher steps, so that we no longer need it anymore. And there's a few good reasons for why it isn't at step 5. The calculations start to fall apart for really high performance buildings. This metric was really designed for houses that are a little farther behind than what we're currently building. So it's not entirely useful at the higher performance ranges. And what this is supposed to be kind of your house built to minimum code, and is supposed to be what we're comparing it to. So here we're comparing it to your house to a minimum code house. How much better is it than that minimum code house? Now, that minimum code house is part of a bit of a problem. How that is actually designed is a bit goofy, and so it's not necessarily accurate or fair. And so that's why this one will fade away in the end. And what we're comparing to is this house down here. So when we see this on our EnerGuide label, that a typical new house, that's the reference house. So this typical new house is a number that the energy model has cooked up based on a set of parameters and stuff like that. And we're comparing this one to your house, and it's basically that percentage better. A few quirks about this is it's about 40% affected by other stuff other than mechanical. Now the MUI is as well, but it's this one is maybe a little bit more so, and about 60% affected by mechanical systems. And heat pumps are actually overrepresented. So if you put in a heat pump in a house, you are probably going to see that you're way off the charts high, doing amazingly well compared to the reference house. So it's a little bit goofy. It fades away. I'm not going to spend much time on it because it will fade away at the higher steps. But it is there and it is available for use now if people need it. So that brings us to step code itself, and what kind of system do I need to do to get through step code? And this is kind of the most common question we get from our contractors, from our designers and our clients to say, okay, well, what do I got to do? We got to meet step 3 because our local municipality requires it, or I want to get the rebate for step 5. So what do I got to do? Tell me what I got to do. And the answer to that is actually reasonably complicated, because it depends so much on the house. And we go back to that integrated design thing, and there may be all kinds of reasons why you would use something versus another thing. Heat pumps may be the most efficient, but in this case, maybe it's a gas system that gets us to the goals that we're trying to reach. And of course, they all have, when I say efficiency, I think we need to define that a little bit. I'm just gonna skip that one and come back to that. So, the simple physics, and Ryan already touched on this, right? If we have a gas furnace, we imagine a vending machine, we put $1 in, we get 95 cents back if we're talking about a traditional gas furnace. A simple cheapo baseboard, we put $1 in, we get $1 back. A heat pump, even a low quality heat pump in the Okanagan, is going to have a COP of 2 or better if it's installed correctly and right sized for the house. And so that means you put $1 in and you get $2 back. A good heat pump's going to be giving you $3 back. And so I think we often confuse cost to run with efficiency. And I think a lot of builders tend to use that sort of interchangeably, because you'll hear a lot of folks say, "Oh, boiler's the most efficient," and that's not normally the case. What they're imagining is that their energy bills are lowest with this piece of equipment. And so that takes us to this, right? Cost to run is not the same thing as efficiency. So we might have a boiler option, which might be least cost to homeowner in colder areas. Because the gas right now, at least in my area, is selling for about 6 to 7 cents a kilowatt hour. Electricity is around 12 to 13. And so if we're using if we have a high heat load, that cheaper fuel, can be a real advantage. The electric baseboard might be least cost to the contractor. They're cheap and easy to install, or maybe we're building spec and we're maybe not too worried about what the homeowner is going to do with it. So that might be least cost to contractor. In the area that I'm in, warmer areas here in the Canadian Riviera, a heat pump is least cost to the homeowner. And that's because they're more than 2 times efficient, and that outweighs the 6 cents per kilowatt hour for the gas that we're buying gas for here. So it really depends on a lot of things. It depends on where you are. It depends on what your goals are, and of course the install cost of the equipment itself. So there's all these different factors, and we have to define best for each project. It's not to say one is better than another. And I want to go back to this graph then, because this is the sort of graph that we produce for our clients when they're asking for information on mechanical systems. And what it's showing you is kind of what step or what MUI you're going to get for for your various different options. And this is a specific house, so this isn't for every house. This is not a generic one. This came out of a specific house, and for this specific house, the electric baseboards, the furnace, and the boilers couldn't get them past step 2. And so for this particular one, we needed we have a kind of a good quality and a medium quality heat pump on there. And that got us then into step 4. So, you can see the kind of differences, right? And they show up very, very differently depending on, what your house was doing. If this is a fairly high energy load house, if it was in a warm climate, I might add, if this was a very low energy load house in a cold climate, these numbers would look quite different. And this comes out of a system that we use. Actually, it's an optimization system that we have that my team built, and can look at thousands of different options in one go. In the Okanagan area, Gilles Lasange has access to this system. He's actually the first one in the area to have it. So there are people in your area that have access to these type of tools that allow us to really look deeply at all the different systems and how they interact with the wall system and the windows and everything like that. So, and that brings us back to here, if we have a really optimized house, we have a very energy efficient design, then we don't need to compensate for a less efficient boiler, for example. We can use that, maybe that boiler is quite a bit cheaper to install. And so we can get away with that if we have an efficient designed house. An inefficient house, things with cantilevers and tons of windows facing north, and maybe a curtain wall or two, those houses are going to need to compensate with more expensive heat pumps. They're going to need to go and get the high performance heat pump, and maybe other things as well. And so really by having an efficient home and starting with that, we can really save on the mechanical systems, and it makes it much easier to do that. And that brings me then to gas systems for very energy efficient houses. So this has actually been a struggle for some homes. We get to a point where the boiler's too big, and actually really tiny boilers or really tiny furnaces just aren't that available. I believe the smallest furnace you can get on the market bottoms out at 18,000 BTUs. And we commonly see, particularly townhouses or garden suites or just small efficient houses that have way less heating load than that. So it is a common problem. One of the main reasons that we would actually recommend people steer away from gas furnaces in our area is because all the options are too big. It's not that they'd be less efficient necessarily in some cases, but they're just too big. They can't go small enough. So the way to do it is with a combi boiler system, and that's having the heat and the hot water run off of the same boiler, and in that way we can take advantage of the boiler size to do two different things. And this works particularly well when you've got a low heat load house that doesn't need a lot, and the system is really mostly just doing the hot water with shoving a bit of heat over there from time to time. So it is possible to do a gas system in a very low load house, taking into account what I said earlier, that if we're running on a system that is only 95% efficient, then we do need to have an efficient house design in order to make that work properly. So then heat pumps, one of the common comments you hear about heat pumps is that they don't work in the winter, and that used to be true. And actually, it's still true today if they're not set up properly. But heat pumps traditionally, 5 years ago and more, they basically shut off in the winter. They didn't have the capacity to continue taking heat out of the outside air at low temperatures. Happy to say that has now changed in rather dramatic fashion. Even medium quality heat pumps, are very good down to very cold temperatures. Arctic Heat Pumps is actually a Canadian company, and they're manufacturing here. You can see the price on that one. It's not super cheap. But I believe that is a package unit there, not just the condenser coil itself. But this one is good down to -20 and still has a COP above 2 at -20, which means you put $1 in that vending machine, you are getting $2 worth of heat out at -20. So pretty darn cold. Penticton once in a while you might get that cold, but it's not for long, and you can probably rely on an electric backup during those few days that happens. As you go further north in the Okanagan, maybe that gets a little bit more common. I grew up in Coldstream and Lavington area. We would see -20 from time to time, although it is becoming less and less common. Anywhere where I live, like on the island here, we never see -20, and this heat pump would have more than enough capacity to supply us for that. In areas like that have high snow, like in the picture there, we want to install them with a little bit of a different technique. We maybe don't want to put them underneath the roof eave where it's going to get piled up with snow. Quite often at the ski resorts and stuff, you'll see them tucked up underneath the eave up high on a little rack, and so that they're not getting covered in snow, and that seems to work quite well. And we even have relatively inexpensive heat pump models that are good down to these low temperatures. So here's a Fujitsu model that's good down to -21. And below -21, it still works. It doesn't have a cutoff temperature, this particular one. So you can go down, I believe it was -35, where it still had a COP of above 1. So pretty darn cold before these things start to fail on us, and easily workable within the region, even up at the ski hill. So that brings us to a bit of right sizing and stuff here. So right sized, a heat pump can also be a combi system, and it can run multiple systems. So all these systems that we run on gas now traditionally, like the in-floor radiant heating, the hot water, the hot tub, the pool, all these different things, all can be run on a heat pump. So there are options for that. Not all mechanical contractors have updated their skills to be able to do this, but that is coming, and certainly it is possible. And also direct electric is possible. I see one familiar name in the list there for Brett Cicello there, designer in the area there, and he may recognize this living room. But this baseboard there is the entire heating system for this particular floor of this house. So that is a right-sized mechanical system for this particular house. Now, this particular house happens to be a passive house, so very low load heating load, but it often shocks people how small a right-sized mechanical system actually is. And on the right-hand side, or the right-hand side, is an electric heating mat that you can't really see the cables there, but that is actually the heating system in my own house. It's about a 1200 watts there, and that heats the entire main floor of my house, which is 2,000 square feet on one floor. So it's quite possible to heat with very low loads and just do it direct electric. In these cases, it's such a low load that we even bottom out the heat pump, so we can't find a heat pump that is small enough to heat these houses. So we just go direct electric, and because there's so little of it, it's actually the best net present value in that case. So it's not a one-size-fits-all solution. It's kind of what fits the project best. So back into right sizing here, and using step code to get that right size. There is an absolute epidemic of huge proportions on oversized mechanical systems in our industry. We see it so commonly. It's probably at least 2/3 of the systems that I see out there are a little bit oversized. Probably a third of those are dramatically oversized. And I know that the Nest thermostat company did a study, because they have all the data coming in, and they found that about 80% of the systems in the US are actually oversized. And it's a huge problem. And mechanical suppliers and contractors really need to start getting this sorted out, because it's causing our clients all sorts of problems. As a builder, it's callbacks, it's maintenance, it's all sorts of things. I'm also paying too much for that system. I want a smaller system, and it's time for builders really to start insisting on a properly sized, actually do the math system. And these are the sorts of complaints we hear from our clients, right? It's too hot, it's too cold, it's too noisy, we're getting vibration, we're getting bad air quality, and these things are they are symptoms of a poorly sized mechanical system, and we see them very commonly. No homeowner is going to phone you and say, "Oh, my mechanical system's oversized." No, they're going to say it's too hot, it's too cold, it's too noisy. These sorts of things. Most homeowners don't understand about sizing. And this is what it looks like in the data, right? We've recorded some temperature data from a few different houses around my area. The one on the left-hand side is actually my house. So flat flat graph on the temperature, and that's because the heating system can maintain the temperature, perfectly flat. It's the right size for the house, and it's working properly. The one on the right-hand side is my neighbor's house. They have a gas furnace that is not properly sized for the house, and that is the furnace clicking on, clicking off, clicking on, clicking off. Every 15 minutes, it does that, and so it's it's noisy. That's noise on, noise off, noise on, noise off, and all day long. So this system is likely to wear out much faster than it should. So it's a real problem, and it's a very common problem that we see. So how do we solve it? Well, your energy advisor will give you these two, or can give you these two deliverables. The one on the left-hand side is the standard permit form, compliance form that all the cities are asking for. The one on the right-hand side is an auto-generated report. It's the EnerGuide report that comes out of our energy modeling. So the one on the right-hand side takes me about 2 clicks to do. The one on the left-hand side takes a couple of clicks to come out of our system as well. Very easy to do, and very useful for a builder that knows where to look. So if we go to one we did here for a house, and on page 2 of this form, there's a section on space heating, and here it says design heating load is 6.34 kilowatts. It gives us an example here. In this particular house, has a gas condensing natural gas condensing furnace, and it needs to be 22,500 BTU. We also have a fireplace there, but that's not generally counted in the kind of the permanent heating of the house. That's sort of as a luxury item. Also has a cooling load, and certainly for the Penticton area, that's going to be a important factor. In this particular case, I believe this is a North Island home, so the cooling load is only 3.8 kilowatts, and there's no cooling system installed in this one. But it shows up in the same way if you're looking at a cooling system. Now, it's important to note that this is not a CSA F280 calculation, so it's not a room-by-room heat load calculation that your mechanical contractors should be doing. If they can't do it, ask your energy advisor about it, because a lot of energy advisors are also trained to do this, and our team does it. So we can do it if the mechanical team can't. But this is giving you a really nice ballpark number that you already have that you can compare to your mechanical system to see if it is right sized. Let's dig into this a little bit deeper too. So if I go to a quote that we received from a mechanical contractor, and I got to give it a hand to this particular contractor. Their quotes are really clear, and they give us all sorts of data that we need to go and check if this is the right size. So they've given us the model numbers of the various units, and even better is they've given us the Ahari number for this kind of combined thing. And your mechanical contractors have access to this. They should be able to look this up very easily. And it's another thing that I'd really like to see contractors sort of insisting on, is that your quotes include this, or at least get me this information, so that we can look it up and we can double check. And with that Ahari number, we can go to this website and look it up in the database as to exactly what this system is going to do, whether it's appropriate for our climate, and if it's going to deliver the efficiencies that we're expecting, or that your energy advisor assumed when they did the energy model. So this particular one here, we have a heating capacity of a high and a low of 45,000 BTU to 34,000 BTU. That's the range that this particular heat pump operates at. Also tells us the efficiencies and the cooling capacity if we're interested in that. So if we go back to our example house here, and we look and we see, well, we needed 22,000 BTU, and we've got a heat pump on the spec that is a minimum of 36. We can see that this particular case, our mechanical contractor has over-specced this piece of equipment. So by a fair margin. This is a modulating piece of equipment, and so the low end is still too big for this particular house. And this is something we see entirely commonly. And so what we would normally do for this particular mechanical contract is we say, okay, the model numbers, the efficiencies are totally fine, but we need you to move it down one size to the next size. And that's probably going to get us into that range where we could, be in that 22,000 BTU range. And we've got to keep in mind that this is peak cooling load, right? So this is the worst day of the year. We need 22,000 BTU. This is most of the year we are not needing 22,000 BTU. So really what we want is probably something that is, about 25,000 BTU and less. 25,000, I say, because a little bit of wiggle room for models can be wrong. Maybe we get a super cold snap or something else goes wrong. So we want a little bit of wiggle room, but we certainly don't need to double the size. And then we want that modulation down to the spring and the fall, where we only need a little bit. We might only need 10,000 BTU to keep this house warm on a spring day. So something we definitely want to be checking. And also, if we look back to that database slide here, 36,000 BTU for cooling capacity, we're way out of line with this the cooling capacity of this particular house. So, this particular house didn't need the cooling, but if we were looking at cooling, this particular heat pump is way too big. And that's the easy way to kind of go and search it out and find it. So it's right on the forms that you can get easily out of your energy advisor. A lot of the systems, I should add, will also show this, like when they come in the box, they'll show what the sizing is right on the side of the box or on the label of the machine. And so you can, take your step code report and look at it and say, yeah, that matches, or oh, maybe that's out of line, maybe we've got to keep this thing in the box and try for a smaller system and save the hassle of having to repair it later. So that takes me to domestic hot water. This is the second big feature in the MUI side of things. And, luckily this part is relatively easy. And the differences between a very good hot water tank and a kind of mediocre hot water tank are actually not that big. So there's not a lot you can really do here. It's sometimes we're using it to kind of shave the edges a bit, but it's not typically the make or break thing. So, fuel choices are basically the same sort of idea. Again, it might, depending on how the house is being used, will depend on what system you should get, right? And we have, really good tanks. We have better tanks like heat pump tanks now that are relatively good depending on the situation. And we have, even extreme efficient tanks and things available now that that'll be kind of far off the deep end on the efficiency side of things. What of this system is best? Well, I always like to say it's better than good. It's good enough. The differences in terms of your step code compliance for these three systems is probably not going to be that much. And I see Tony there asking about solar water heaters. In this particular case, yes, they are. They would be recognized for the step code that would be factored in. So you would see a decent bump there. Solar PV is not, because that is considered generation. So we wouldn't see it there. But a solar hot water, just the way the system works, would be considered. Those ones, though, it's a challenge. The solar hot water, we're starting to see it kind of die away a little bit because it requires some pumps and some maintenance. And in cold areas, the manufacturers all say that you're supposed to drain it in the winter. And well, that's kind of the time when we want it. So I know in reality, a lot of the systems can be run in the winter, but that's not what the manufacturers are telling us. And they tend to be a little bit more expensive. So if you're going to get solar systems, what we're seeing now is a shift from the solar hot water to just PV, right? You can get 3 more PV panels and heat your electric tank and kind of come out on top. So we're starting to see that system sort of diminish. The solar can theoretically generate more energy. The solar hot water can generate more energy than PV can, but the challenge becomes storing that energy. So solar hot water for your swimming pool, great, because we've got a huge body of water to store the energy in. Solar hot water for a 40-gallon tank, not so much. I mean, that's, you know, 15 minutes of energy on that solar panel. So you just can't store the energy that it can create, and so it's not necessarily, you know, not necessarily a winning solution because of those sorts of things. So you know, what we're seeing is just a lot of half decent electric tanks. You know, the John Woods of the world, right? The ones we see in every spec home, and the difference between them and like a really super good tank is pretty slight as far as the effect it has on the overall. We do see a lot of boilers as well, but you know, the important thing with a boiler, I think, to recognize is how are we using this hot water? If we've got a family with teenagers in the house, a tank may actually be their best option. Because, you know, the idea is you're heating it with a candle slowly, and you're not really storing it for that long because their water load is high. If you've got a retired couple that's maybe not showering every day, not using a ton of water, then maybe the boiler makes sense because you're not storing that, but you've just got this big flame that comes on from time to time. So again, defining best is a bit of a, you know, bit of a trick sometimes.
Thanks, Mark. Hey, we had one more question in the Q&A
Oh, yes,
from
I see it there.
Drew. Yeah, so if
so the question is, in the Penticton area, if you have just a heat pump, does a backup have to be an electric, or can it be a wood burner stove? Good question from Drew. So this is a code compliance question, and the short answer is sometimes. There's a nice, direct, clear answer for you. A wood backup, if it is a fireplace, typically would not be allowed because you have to take action in order to heat the home. So most jurisdictions will not allow you to have a wood fireplace as a backup because you have to be there to light it. So if it gets really cold when nobody's there, the whole house is going to freeze if, you know, your heat pump isn't working. Now, a lot of jurisdictions have said, well, we now understand that this heat pump is good enough down to -25, and we never get to -25. We had a really good discussion in the Invermere area about this because the heat pump can heat the whole house very cold all year round. We don't need to have that electric backup. So in that case, we did not do the electric backup. We don't do electric backups typically in the Victoria area either, because the heat pumps are good enough. You know, if you're way up a ski hill, you know, that might get a little dicey, and so you might want that electric backup. The electric backups, though, I mean, they tend to be pretty cheap, and they don't require maintenance. They just kind of sit there if they're not doing anything. So, you know, it for code compliance, that tends to be the kind of easiest way out. And if we're using it for 3 days a year when it's down, you know, past -25, tends not to be that big of a deal. The wood, of course, if I'm living in the house, I'm probably going to throw some wood in the stove and maybe not rely on that wood backup. But for code compliance, you know, we probably want that electric. Hopefully that answers the long-winded. That's the long-winded version.
And to speak on that, Drew, yeah, we here at the jurisdiction of Penticton, we wouldn't allow the wood as the backup. We'd want to see something, as Mark touched on, like electric that would just kick on without having to manually stoke the fire and such. So, yeah, really good question though. So then I'm going to leave hot water and heating systems behind and start talking about some systems that get a fair bit of buzz now, and we are starting to see much more commonly around various different areas, and that's fresh air systems. And notice I'm calling this a fresh air system, not a heat recovery ventilator, and that's because I have never sold a HRV based on calling it an HRV. No client of mine has ever understood what I meant when I said HRV. Even some of the engineers that we've worked for. So we call them fresh air systems, and people you know, react much differently to that. They say, oh yeah, fresh air in my house. Oh, I definitely want that. Yeah, we'll get a whole bunch of that in there. That's definitely what we want. But an HRV sounds complicated and expensive, so we don't want that. So we call them fresh air systems. And now in the modeling for this, so if we're talking about step code compliance, a fresh air system will help you a little bit
on your MUI and a little bit on your Teddy. It's actually a disappointingly small amount. It's not like, oh, we're going to double the efficiency of the house because we got an HRV in there, even a really good HRV. And that's simply just that there isn't a huge amount of heat loss from the ventilation air typically, at least not enough to really skew the scales. So when we recommend an HRV to get past code compliance, it usually means we're already kind of right on the line and we're trying to give ourselves some wiggle room, and that'll pull us down that little bit. The colder area your area is, the bigger the effect this will be. So if you start building up in 100 Mile House or farther north, you're going to see a much bigger jump than you would in the Penticton area, and certainly on the Vancouver Island area, it's a very small jump. Not insignificant, but it's not like we're doubling the efficiency of the house or anything. It gets more spectacular if you start doing things like not having bathroom fans, like just using the HRV for the bathroom fan, which is a very practical thing to do these days. They're also, so the main reason we see them and the main reason we recommend them to our clients is that all these other benefits, right? We get humidity management, we get fresh air, temperature control, some free cooling, we get silent bathroom fans, and in particular for this summer's conditions, the air filtration. So on my HRV that I have in this house, we have a carbon filter on it, and that filters out the forest fire smoke. So our air quality inside was really good. In fact, you couldn't smell the forest fire smoke, and we didn't get as smoky as you guys did this summer, but we definitely get smoky every summer now. And we also have a neighbor who is really into smoking weed, and we don't smell that with our carbon filter in place. So they do have the ability to do some really serious filtration, and in my mind, that is the sort of reasons why we would put these systems in. We also talk about them as one upgrade with air tightness. As we get more and more airtight, of course, we lose the ability of that house to naturally vent air. And so a managed air system becomes much more critical for humidity buildup and all sorts of different things. So when we're talking to clients, we're talking about typically air tightness and ventilation as one upgrade. They are one package that we do together. And there's data to show that this is really a good idea, right? So here's some more data from my house, because I'm a nerd and we have sensors all over the place and stuff. And so the on the left-hand side of the graph is actually the sensor in my house. On the right-hand side of the graph is a sensor in my neighbor's house. And you can see a vast difference. And the difference is that we have a good, properly running, properly sized heat recovery ventilator in the house. My neighbor does not. And now this is measuring CO2 because it's an easy gas to measure. But what we know is that when CO2 levels are high, there are other associated health problems. So, your VOCs are also high, your particulates are probably also high, and all these other different things. So, and CO2 itself makes you sleepy and different things like that. You can actually, on this graph, they frequently jump over the line to where the World Health Organization says CO2 levels are unhealthy. So, and this is common. This is a pretty normal house. There's nothing wrong with the neighbor's house, actually. It's a pretty normal house. On the house with the ventilation, we're at background levels of CO2. So, pretty big difference in the performance of the health performance of these houses. And of course, there's all sorts of common brands, right? And when we're talking about HRVs and step code, typically we're looking for something 70 to 75% efficient. There's a lot of common brands with that, and they're plenty good. They run quietly. They have decent controls, and all sorts of things like that. So lots available on the market. All the common furnace makers have a brand that it would be plenty good enough for step code. Want to pause here and say a lot of folks will use the term ERV and HRV interchangeably, and they of course look the same on the outside. They are not actually the same. They're close, and if somebody uses them interchangeably, I typically don't correct them, but there is a kind of a key difference here. An HRV recovers heat only, and it requires a drain at the unit because it's allowing moisture to go out that way. An ERV recovers heat and humidity. Typically, there is no condensate drain on the unit. Typically, they're slightly less efficient, very, very slightly. It's not that big of a difference. And so in dry areas, we typically want to use an ERV. In very wet areas, it's typically an HRV. So my hometown of Victoria, we're typically using HRV. Typically, the West Coast is all HRV. Although there's not necessarily a downside to using an ERV. It just, you don't get the drying, which is kind of nice to have on the West Coast. In the interior, you're probably seeing mostly ERVs. Certainly on the prairies, you definitely want to be using an ERV because it recovers that moisture as well, and we maintain the humidity level throughout the winter, for example. So there is a difference. They're not interchangeable, but they do a lot of the same things. The basic anatomy of an HRV, I think, is not well understood by some mechanical contractors, but also builders in general. It's a bit of a newer tech in houses, and haven't been super common for a while. They're just starting to be common. The nice thing is they're actually pretty simple machines. They're really easy to repair. We service and repair some models of HRV, and they're really kind of nice because they all have these kind of just basic components. They're actually really simple machines. They have a case. They have filters, they have fans, and they have a heat exchanger. And that heat exchanger just works like any other heat exchanger, air passing by air, and the heat is transferred. The better the HRV, the better exchange you're going to get, the better filters you're going to get, the quieter, bigger motors you're going to get, and you're probably going to have better controls with it as well. So, that's usually what you're paying for. If you're seeing a $1,000 HRV versus a $2,000 HRV, usually you're paying for filters and a heat exchanger. That's the difference. The filters, in particular, I think this is something that is so important with our fires and stuff getting worse and worse. On the bottom there on the left, I've got a picture of the top filter and an old filter and a new filter, and the top one it's a filter out of my own house here. The top one, the reason it's black is that's city soot. So that's my neighbor's oil-fired furnace that, even though there's huge rebates to get rid of, they won't. Boggles my mind, but whatever. Exhaust from cars and things like that. So if you're living in downtown Penticton, you're probably going to see filters like this. Certainly in forest fire season, you're going to see filters like this too. You're going to see that black soot on the filter, and that's what's coming into your house. That is in your house if you don't have a filtration system. Now, for me, filters, this is one of the key things that we shop for in an HRV. When I'm looking for a model, I want to ask about the efficiency of the machine itself, but I also want to ask about the filters. Can I get them? Are they easily to replace? Do they not cost a fortune? Is my homeowner, after I deliver this house, are they going to be able to figure this out, or do they have to get out 15 different tools to try and change this thing? Which essentially means they are never changing the filter if they have to get out more than a screwdriver, if that even. Really, ideally, it's just a clip open the machine, pull it out, and pop in a new one really easily, and then maybe we can, the homeowner will actually do it. We've seen too many cases where homeowners didn't understand or didn't know that they needed to change these filters, and it's not uncommon to go to do a service call that the HRV isn't working properly and it's making weird noises. You pull the filter out and there's 2 inches of cat hair on that filter, and it's no surprise why it's not working. And that then brings me to controls for these things. This is one area that's really come a long way in the last few years. It's no longer just a machine that kind of runs in the background. We're actually taking action with it and using it to benefit systems. So, for example, bathroom switches is a real big one. So instead of having a bathroom fan, we have a bathroom switch on the wall for the HRV, and it boosts the HRV. So it was taco night or something, things got bad in the bathroom, button on the wall takes care of that really quickly and quietly in a very efficient way. And one of the key things too is that there is no off button for these machines. And that's done on purpose, right? We don't want to shut them off. We want them to, we can run them on low speed, but we want them to be running all the time. And that is by design. And of course, they will typically have high, medium, and low speeds, depending on what's going on through the day. And one of our things that we do for our homeowners is we spend a couple of hours before move-in coaching them on how to use this system, because then they're going to get the best results out of these and really have that pristine air. For the contractor, setting these things up does really matter. Vent position is something critical. We've got to consider this, and this really goes back to that integrated design, right? If we're not designing the house for its energy efficiency, for its mechanical systems, and specifically for its HRV, it's not going to work properly, right? So the vents, some of these vents in the picture here, like that, the one on the left there, if that is tucked up in a corner, that vent isn't going to work properly because it's designed to shoot air out in a cone. If it can't do that because it's hitting a wall, it's not going to work effectively. The one on the bottom right there, that's an intake vent on the bottom there, kind of getting a little close to the ground, and potential to suck up leaves and things like that. Actually, the bigger problem with that vent is that it's on an alleyway, and cars frequently sit there and idle, and so it's sucking in the exhaust from the cars that sit there and idle. Why they're sitting there and idling, I don't know. It's probably because there's a drug dealer in the house next door and somebody's waiting for their next hit there. But it's a little bit of redesign and consideration of where those vents go makes a huge difference in the house. So how do these systems integrate? Something that's at least very poorly understood amongst contractors. I think it's not, it can be a separate system where it's on its own, it's got its own ducting. It can do that. That's typically the way we set our houses up, because they are doing separate things. But the more common way is for contractors to integrate them into a system that is already there. So they can be integrated into a forced air furnace where the HRV is essentially providing the cold air return to that furnace. Nice thing about this is it uses the same ducting system. It's very easy to install. The cons is that it doesn't have a lot of design flexibility, and it will typically have lower performance because as soon as that furnace fan kicks on, that HRV is overwhelmed and it's just kind of passively sitting there trying to hold on, sort of thing. The fans aren't actually doing anything at that point. You can have the HRV in a combi system. So we see this commonly in quite high performance houses where you'd have a gas boiler or a heat pump supplying a radiator that is in actually the duct of the HRV and supplying the heat that way. The nice thing about this is that it's very controllable and flexible, can be very efficient, and the ventilation air is not necessarily affected by the heating needs if they're separate. So can be a good way to go there. The cons on this one is, of course, that it requires its own ducting, and the HRV delivered heat only works in very low energy need houses. It's because the HRVs just typically aren't pushing a lot of air, so you need a very low energy load house to do that. Something in the passive house range typically. So it can be set up a whole number of different ways. What I think is most important is that all the systems be commissioned and tested, and that goes for heat pumps as well. It's not just to plunk this thing down on the pad, light it up, and away we go, right? It's, is the system actually working? Are we testing the voltages on it to see that the pump is working at its right speed? Are we testing the flow rates? That sort of thing. The high performance HRVs are actually sold with commissioning. And so that when you buy one of these, you phone back to the manufacturer and say, hey, we're done installing. A commissioning agent comes out and actually sets it up and programs it and things like that. The cheaper models don't have that. Of course, I would really like to see that because we frequently see that the HRVs aren't working properly, or and the same thing goes for the heat pumps as well. Most of the manufacturers will require that the heat pump, I believe furnaces would lump in there too, that they are actually commissioned. There's a commissioning checklist that the contractor needs to do on startup, and some testing to make sure that they are actually doing what the manufacturer thinks it's going to do. And then, of course, I got to pick on some bad stuff here before we leave. Ryan, we're over at 10:30, right? Is that correct? I believe that was the goal. Hopefully, it's the goal because that's what I was aiming for. And so you know,
Yeah, sorry,
location.
yeah, that's correct.
Okay, good. Good. So, you know, location, right? This goes back to that integrated design and why I think everybody should really take advantage of the integrated design offer. You know, integrated design is really just like cooperation, but for builders. You know, sounds maybe intimidating, but like, let's all just get along and talk to each other. Sounds a bit like a Sesame Street song. And it really is that easy. Like, how hard is it to have a meeting and say, how is this going to interfere with your stuff? That's really all integrated design is. I mean, we can make it sound fancier with all sorts of reports and stuff like that, but really most of our integrated design projects are getting together at Tim Hortons saying, hey, structural engineer, how is this going to interfere? I got to get a pipe over there. How's that going to interfere with you? And so here, you know, here's some examples of things that have gone wrong, right? That one on the left-hand side is an HRV intake, but they've basically set it up to be a leaf sucker. That particular one needed a bunch of redoing because there's so many leaves coming in through that intake. The machine didn't function. In the middle, it's actually a sprinkler pipe in the way there, and this particular vent, again, it's one of those ones that's designed to shoot as a cone. So it's the wrong type of vent for that location. It's got something blocking it, and it's not effectively delivering fresh air to this room. The one on the right-hand side, you know, don't even get me started on this thing. It's obviously a light behind a bunch of HRV ducting. You know, how hard would it have been for the electrician to talk to the HRV guy? I guess pretty hard because it didn't happen. That light is going to melt all those different things. You know, a little bit of integrated design kind of goes a long way. And this particular one is also, I think, a really good argument to not have fixed price contracts anymore. I think fixed price contracts really need to kind of go away, and we need to go to more of an integrated project delivery. Because that allows us to help each other, right? The mechanical contractor here and the electrical contractor followed their plans. They all got paid because they did their job. But as you can see, this system is not going to work. It's going to have some pretty major problems, even though everybody did their job according to the plans. Under a different setup, we can say, oh, electrician, I'm going to be in your way, or vice versa, and maybe solve that problem versus being forced to got to do the plans because that's on our fixed price contract. So there's some arguments to be made there for, you know, alternate contract methods. So, you know, other things here too, that one of the common things we see, all too common, is ducting in the attic. This is just a major no-no. We really got to stop doing this. Ducting in the attic or ducting in the floor of the garage. This particular one is in the floor of a garage. Where the homeowner, you know, called us back. Luckily not my project, but we were the service tech on this particular HRV, and the homeowner called us back in complaining that they were getting a gurgling sound in their bathroom, and the bathroom didn't really seem to be working properly. And so what we found is that the path of least resistance was through the garage for the ducting, and so that's where it got run. There was 5 gallons of water in each one of those pipes, and they'd filled up and started to sag down, and filled up more and sagged down some more. And so, you know, basically a non-functional HRV. Luckily, the pipes are plastic, so it held the water and didn't leak everywhere. Yeah, you know, pretty serious consequences to not doing an integrated design approach here, where you would maybe somebody might realize that that these ducts are running through a cold zone. And you know, we've seen this a lot where ducts run through an unheated crawl space or something like that, where if you're going through with a metal duct, if you put 20-degree air in at this end, by the time it gets to the other side of the house, it's whatever temperature the crawl space is. You're not providing heated air to the other end. And you know, something entirely common, aside from oversizing, this is probably the second most common issue we see with mechanical systems that are just not properly designed, not properly commissioned. The solution in this case was to insulate the heck out of this cavity, put a drop ceiling on this area, and insulate a bunch extra around these pipes, and that did solve this problem. But sure, a lot of extra work for something that could have been solved in design. So I'm going to start leaving it there and open it for questions here in a bit. So we've got about 15-20 minutes for questions. But I wanted to point everybody to these two manuals, which are available on the energystepcode.ca website. They are a builder guide and a design guide. Maybe somebody could explain to me why designers can't read in a regular book form. They have to be landscape. I don't know why that was done. Some design reason, I'm sure. But the builder guide is very good. So is the designer guide. The designer guide is mostly geared towards part 3 buildings, and the builder guide is mostly part 9. They both have a lot of really good pictures in them. They both got details in them, various different techniques. They've got all those graphs, a lot of the graphs that I showed earlier in them. They're written in kind of plain language, so real people can read them. And some of the parts are getting a little out of date on these now. It was 2018 that these were written, but still definitely worth a look, because all the concepts are there that'll help you be really successful in your step code journey and getting those rebates and such along the way. And so I was going to leave it there and leave lots of time for questions and see where we can go with this.
Wow, that very informative, Mark. Thank you very much. Yeah, a lot of good information there. And yeah, well, we have Mark here. If anyone has any questions for him, like I said, feel free to use the chat, raise your hand, or use the Q&A.
Yeah. And I want to, while we're waiting for people to think about questions there, Ryan, I wanted to chat just quickly about city's policy, particularly on that update for the requiring the EnerGuide label for the permit and stuff. I just wanted to say that's actually it's a good policy, and it's something we're seeing a lot of municipalities pick up, and particularly a start, because that then ensures at some point along the journey that the model file has gone through some sort of quality control. And if we don't do that, then it's just me cooking up numbers in my basement, and so it's a good policy update to see there for sure.
Yeah, that's great. It is a little tough being early adoption. There's some hiccups along the way, as far as disclosure, the platform for it, but that's all coming down the pipe. So, and the label, of course, is. Do you want to explain actually to the builders how they get that label through? It has to be a third-party verification, such as I think you are one, right?
Yeah, and so the label, the EnerGuide label, most of your all of your energy advisors, I'd expect, will be using the HOT 2000, the EnerGuide system. We also use the Passive House system, so we can go through that path as well. But that tends to be for those really exceptionally high performance projects. Most of us are going to, it's probably over 95% are going to be using the EnerGuide system, and that system is the same for retrofit houses as it is for new houses. It's pretty easy. When I do an energy model, I'll do all the math and such, and then I will send it off to a third-party organization to do quality control on it, and then that project gets registered with NRCan and has that official energy label. So it's a bit more of a robust system. And when we're talking about code compliance, that really matters. If we're talking about like a $50 window rebate, like who really cares, right? But when we're talking about inside the code or outside the code, that is that third-party quality control is really critical. The engineers do it, so should the energy advisors.
Great, thank you. We have a couple of questions in the Q&A. Do you want to access them? And
yeah, definitely. So,
sure.
First question from Brett. Has there been any additional discussion in regards to the F280 sizing mechanical and the results in the HOT 2000 model or the PHPP, which is the Passive House model? And so they're constantly finding that F280 oversizes the loads. And Brett, you're right about this when you're talking about higher performance houses. Now, knowing the houses that Brett designs, his houses are going to be on the top end of that performance. You know, we've worked on a couple of Brett's passive houses and stuff. So those calculations kind of fall apart at the very high end of performance. So the past step 5, we'd probably be using you know, a PHPP model or something similar that has a better orientation towards that very high performance. For average housing, like the step 3 to 4 type houses, that I think are going to be more common for the next few years, that F280 is okay. It's, I would say, good enough. It gets us in the right ballpark. And usually, especially with heat pumps, our sizing options are 1, 1.5, 2 tons. You know, they're not, you know, we're not down to the kilowatt hour, so we're kind of picking a pretty big target, and so for that sort of thing, it's good enough. It's better than guessing, and that's certainly what we're after. Is we don't want to be guessing anymore. Hot 2000 is a model, that's the energy model that the energy advisors are using. It provides a basic, just generic value on its, as one of its standard outputs. It does have the ability to do a room by room calculation. Although some parts of that are becoming out of date, it is possible to do it and provide that feedback. So your energy advisor does have a tool that can do it and sort of produce that. But that is a separate certification outside of the EA certification. It's an add-on certification to get that F280 certification. So not all energy advisors have it. Certainly it is becoming more common though. Good question from Bill here. What is more cost effective for heating, gas or electricity? And good question, age-old question, I think. And that really depends. So it depends on where you are and what your heating load is and what your gas cost is. So in Victoria, you know, here in the Canadian Riviera, heat pump heating is more cost effective, pretty much no matter what you're doing. Now, for a while that wasn't true, but now with the technology of heat pumps and the temperatures we're normally at right now, that is true. It's pretty much electricity only, and we're starting to see that. We see very few gas furnaces going in. The odd boiler for the heated floor, but very few gas furnaces going in our area, and that's simply because you know, gas is you know, 0.95 of the COP, and even the worst heat pumps in our area are 2+. And if gas is selling at 6 cents, electricity is selling at 13. Well, we just need a COP of a little bit more than 2 to be cheaper to be running on the heat pump. It's a little bit of a dicier answer in different locations that are colder. So when we look at Prince George, the heating loads are a lot higher, and the heat pumps are less efficient because of the cold. So that math starts to kind of trade off a little bit, and it depends on where you are. There's sort of a fuzzy line somewhere around like kind of Revelstoke and into the interior there, where on the south side of that line, you're clearly better off to have a heat pump. And on the north side of that line, you're probably better off in terms of running cost with a combination of heat pump with gas backup. And some sort of combination there. So that's what we're seeing up north, is those heat pumps with gas secondary system, heat pump being the dominant system. But you know, and then probably start to see those, you know, increase. And as heat pumps get better, that kind of fuzzy line starts to move north. And so it's not really a clear-cut answer what is cheaper, because it depends on so many different things, and even town to town, right? If you're sitting at the base of the ski hill versus the top of the ski hill, you know, that's again going to be a little different. So what I would say is there is no rule of thumb. You got to do the math, and that math isn't very hard to do.
And one thing to take into consideration, of course, in the Okanagan is our cooling demand. We have like 4 months out of the year that it's, you know, we're cooling dominated. So that might make you choose a heat pump opposed to a furnace, just getting better bang for your buck throughout all seasons.
Exactly. And you know, that's a really good comment. For, you know, a lot of people are installing AC, and I was shook my head at that, because why would you just install AC? You're essentially installing a heat pump with no reverse gear on it, and the reverse gear is like another $50. So just get the reverse gear, and now you've got a much more efficient system, even if you have that gas backup in there, and that's worthwhile to you. an AC unit is just a heat pump without a reverse gear. So you might as well just get the heat pump. The AC it just doesn't make any sense anymore. I bogs my mind actually why people still install those, because they're just not worth it. Just go for the heat pump. So from Tony here, I mentioned that fuel source is soon to be incorporated into the calculations. Is electrification the optimal choice for a residential house in southern BC? Again, I'm going to go with a wishy-washy consultant answer and say maybe, which is a really annoying answer, I know. You know, so these changes are still coming. It hasn't been signed into law yet. It is expected that it will be. I wouldn't say there's any, again, one size fits all thing. There is likely to be a kind of graduated system where the colder you are, the more leeway you have to produce more CO2. I haven't yet heard any exemptions for renewable natural gas, which of course would reduce the CO2 significantly, or all the way. But and it's simply because it's hard to tie a property to a specific type of gas if it comes out of the same property. You know, there's some legal issues, I'm sure, for some lawyers to sort out and getting that figured out. But it'll depend. It'll depend. Whatever happens, it will likely be slow. And sort of a gradual change. It's not like all of a sudden tomorrow we all have to be on heat pumps and only heat pumps. That's not the way it's going to be. It's going to be a slow shift and trend towards electrification. And certainly at some point, I would suspect if we were having this conversation 10 years from now, we would be looking at like only electric throughout the whole province. But you know, it'll be a slow transition to get there for sure. It's not going to be something that happens overnight.
Hey, Mark, this is Stephanie here. Thanks for that answer. And thanks for speaking to renewable natural gas there, because we just opened up the program again to allow customers to sign back on for their options. And we have more and more supply coming on over the next few years. So to 2030, we plan to have 15% of our gas supply be renewable natural gas. And we are working with the regulators to determine how RNG would fit in as part of that solution. And we're also looking at potentially different tariff options for RNG and how we could tie that into to all the different requirements that are coming up across all the different municipalities. So yeah, no, that's great. Thanks for mentioning that. And we hope that with a product like that it can leave those solutions open to customers so that they have the option to choose what's best for them and their home and their systems.
Yeah, exactly. And that's a really good point too. Like it's a transition, right? Like that's why they call it the 2030 plan, because it's a transition, right? Where it's not business as usual. That's gone. But this transition away to a more sustainable fuel source and not only a more sustainable fuel source, but a more sustainable way of using that same fuel. So yeah, some exciting things actually there. I recommend everybody read that 2030 plan, because it is
it's awesome.
quite a transition. It'll be fundamentally different for how things have been done in the past, actually.
And I think that's what we need to do, we have to move things forward, right? And we still have to leave the options open, because there's a certain cost factor and resiliency and all of this, like how much energy is there to go around to all our customers, and in what forms does it need to take. And then along with renewable natural gas, we also have some other innovative technologies. Like, I don't know if anyone's heard about the gas-fired heat pumps. So those are on the horizon as well for both commercial and residential. We currently have a bunch of pilot programs in the market, and we hope to have some market offerings available next year.
Yeah, and I'd add that you know, Penticton and all the Fortis electricity area is really at a strong advantage, because Fortis supplies both the gas and the electricity, and that is a real strong advantage because it makes it much easier to get all their rebates. In my area, there's always kind of this somewhat political discussion as to whether, you know, we're targeting Fortis rebates or we're targeting BC Hydro rebates. and it really does take a lot of options off the table because you have to be all one or all the other. So you know, the Fortis area really does have quite an advantage there of having that customer choice to be able to kind of figure out, you know, what is really the best solution given the house. So
Yeah, I agree. Thanks so much, Mark.
One question I thought of, Stephanie or Mark, is when we get into these LES systems, these new gas heat pumps, when they're going to be say a better efficiency than COP than one, would they fall into a category of an LECS system?
good question.
Yeah.
So certainly certainly with anything with a COP of 1 or better, which a gas-fired heat pump would qualify for, that is probably going to be good enough for most homes to get to step 5. You know, your average spec home, that sort of thing, that, you know, that's probably going to be able to get you to step 5. There's a few cases where you have really small units, like a very high density, you know, multi-unit sort of situation where, you know, you might need more efficient systems than, you know, if it was just like I know that the current models of those heat pumps are a little over a COP of 1. And they're getting better. Like, you know, within a few years, I fully expect them to be a COP of 2 or 3. You know, those really high density places where their base loads are high and things like that, we might need to see a little bit better than that. But certainly for the medium and short term, you know, something with a COP just slightly better than 1 is going to be just fine all the way up to step 5. So.
Yeah, nice. Now, one question I get, this is related to the energy compliance reports. Does it matter how you calculate the reports? Say one part of the MUI is % better, the TEDI is by the metric. Of course, the air tightness is the air tightness. Does that change how you calculate, say, if the MUI is reaching, you know, step 4 and the TEDI is reaching step 2? Where does that come into play on when you're finalizing what step is actually achieved on the form?
It's always your lowest, right? So it's the lowest. Well, whichever one is lowest, that's the step you reach. So if you got a step 5 air tightness and a step 5 TEDI, but only a step 2 MUI, you are step 2. You know, it's not uncommon for us to see a step 4 or 5 TEDI, a step 5 MUI, and a step 2 air tightness. So it's always that lowest one. And there are, you know, there are different, I mean, we could do a whole different thing on TEDI, but you know, there are all sorts of different design features that make that work. Air tightness, the same sort of thing. And but yeah, it's always the lowest. So it's not, you know, we often do get clients saying, well, what if I just added a heat pump? And if it's the TEDI we're worried about, heat pump's not going to do anything for you. And so if it's the MUI we're worried about, well, heat pump's probably going to set you way past where you need to be. The numbers and the targets aren't really that strict. So if you're trying to get to step 3, 4, you put a half decent heat pump in, whether it's got a gas backup or not, you're going to be well past the target that you need to be at, unless something has gone major wrong.
Yeah, good. Yeah, and that's a good point there too. Like, you know, Penticton's referencing step 3, and you know, that's not a high step yet, but it's we're hoping that the local builders and designers are taking this time to understand what we're talking about here, and gives them the chance in the few years to come when we're reaching the higher steps of the code easily. So
yeah, and that's what I really like about the steps, right? Is that you can kind of ease into it, and what we're finding, and when we look through our database of homes here, is we're of the ones that are targeting or have to get step 3. we're seeing very, very few failures. It's about 5% that don't pass as designed. So when they come in just a set of generic designs, it's only about 5% that don't hit step 3 as designed. So this is just, in our area, that's just best practice, or even not even best practice, maybe standard practice. We'll get you step 3. I don't have a lot of projects in the Penticton area. I think we only have a couple, but our projects in the Kelowna area, in the Kamloops area, little colder than you guys there, and it's the same sort of thing. We're seeing builders come in just with their standard practice and hit step 3. And so if step 3 is kind of standard practice, that means that doesn't cost us anything. Probably we're going to have to pay a little bit to get to step 4 or 5. But what we're also seeing here, particularly on parts of Vancouver Island where builders have had now 5 years to practice, we've been at step code for 5 years now, and more in some other areas. We're seeing them hit step 4 or 5 now without any extra cost. They've just modified what they were doing slightly, got good at doing the air tightness just by practice. A few builders telling me now that it's a couple $100 to get the apprentice to walk around for half a day and check for holes on the envelope, and that's our air tightness. We're using medium quality heat pumps because that's what our clients expect, not because we have to, but because that's what the clients expect. You could do it with electric baseboards if you wanted, and then the envelopes, it's mostly just 2x6. 24-inch on center framing, and that's, we're talking in the step 4 or 5 range for those kind of houses. So it's not like we're talking passive house at step 5 where we got the 13-inch thick walls and things like that.
And I like that you hit the nail right on the head there. This is the time for builders, designers to play around with their assemblies, their systems, and take the time to figure it out and minimize those costs in the long run. So yeah,
the difference between step 3 and step 4 is not installation, it's practice.
Mm-hmm. So yeah, agreed. Yeah. I don't know if we have any more questions. Looks like we've pretty much answered all questions.
Yeah.
So yeah, at this time I'd just like to once again thank Stephanie for Fortis being here and letting us know about all those rebates and incentives. I really hope people will start considering that IDP rebate, and really taking that practice. And as Mark said, it doesn't have to be complicated. It's just about communicating with all the stakeholders involved in the build, and that can go a long way. Keep cost overruns, keep the cost down. So that's pretty important. And of course, Mark, I'd like to thank you for all your valuable information. I think we all got a few good takeaways from this today. And of course, if anyone has some more questions later on they think of, they're welcome to email me or get a hold of Mark or Stephanie. So that would be good. This recording will be on the Penticton website in the future under energy efficient homes. So look for it there probably in a couple weeks. You'll be able to go over everything we've said here today, and in case you had a few more questions to be answered, that was on here today. So yeah, thank you everyone for joining, and thank you panelists. Really appreciate everyone taking the time to learn. So
Thanks for having me.
Great, thank you.
Thank you. Bye now.